Hello guys, in this video we'll build Codeshare IO clone using Rust. We'll be using all of these concepts today. We'll build an application with WebSockets because as you can assume it's a Codeshare application. We have to share code on real time, and then we'll build a front end using client-side rendering. We'll build a backend where we'll handle the sockets, separate binaries for front end and back end, and then a single config for multiple bins, which is a concept that you will see probably one of the first videos on YouTube. And then you will also experience async programming. So let's begin. This is our motivation for today's project. You can go and Google codeshare.io. So just to give an overview, let's say I go here and I start typing something, and then I share link with my friend. They on real time can view and edit whatever I am typing here. So this is what exactly we'll be building today, not the entire website with all the features, but we'll be building the code sharing part and the link sharing part. So it's gonna be very exciting. Let's get started. So back to our ID, let's first of all finalize our project structure. First of all, inside the SRC, we'll add two directories, backend and frontend, for separate binaries. Inside frontend folder or directory, we'll add client.rs, and inside backend directory, we'll add server.rs. Along with client and server, we add some additional files, cache.rs for caching, server.rs, and model.rs for our model, socket.rs for our WebSockets. And on the client side, we just need client.rs and template.rs. And in the server, we include these modules. And in the client, we include these modules. Now let's move to our cargo toml file where we add our dependencies. Now, since we have a couple of binaries, there will be some dependencies which are exclusive to frontend and some dependencies which are exclusive to backend. But if we add everything in here, just like we do usually, then it will build all the dependencies for frontend and all the dependencies for backend, which is not what we exactly want because we want to be optimal. So let's see how can we do that. First of all, we'll add Axiom with version as latest and features as WS for WebSocket and JSON, and then optional as true. Then we'll add ask AMA for templating with version as latest and optional as true. Then we need Surday for serialization and deserialization, version latest and features as derive and optional as true. Then we need Tokyo for async programming with version as latest, features as full and optional as true. And lastly, we need Tower HTTP for course with version as latest and features as course and optional as true. Now let's add that features thing which will help us build only the dependencies which are required for respective features. So we'll just add features and front end as a feature, and what is required is ask AMA, Tokyo and Axiom. That's all that we require for front end. For backend, we need Axiom, we need Tokyo, we need Surday, and we need Tower HTTP. Now let's add the binary. So we'll just do bin and name as frontend, path as src frontend client.rs, and required features as frontend. Similarly, for backend binary, we'll just say name as backend, path it src backend server.rs, and required features as backend. That's all that we need to do to be optimal in building our dependencies while we build our project. So once our dependencies are added, we'll move back to Project Explorer, and here we'll add a templates directory, and inside which we'll add an index.html where we'll add all of our HTML. With our project ready for coding, let's start with the client side first and then we'll move to the server side. So first of all, we'll add the rendering part, and here first of all we'll add the index template to render our page. Index template and derive template with path as index.html, which refers to this file, and then pub struct html template t and pub t, and then we'll impl into response for our html template to the rendering part. So into response for html template t, and then we'll implement the member, which is into response. So if match self dot zero is okay html, then we will just say html and html dot into response. If that's not the case and we get an error while rendering, we'll just print that error while rendering, and we can print the error, and then we will just return status code as internal server error, and format, or let's just add a string message that says error rendering, and then into response. That's all that we need to do for rendering part. Now let's move to client.rs, where we'll add our serving part. So let's make this Tokyo man async, and let's add a handler. So async fn index handler, and this returns impl into response html template and index template, and we'll just add the serving part. So app router new route on slash just get index handler, and at the listener, so Tokyo NAT TCP listener bind on port 3000. This is our front end on port 3000. Await, unwrap, and axiom serve. So listener app await unwrap. This is all that we need to do on client side for rendering. Now let's go ahead and serve some dummy HTML, and then we'll also add the business logic. I just added this HTML with some CSS and Bootstrap. This will be our UI for today. I'll share this in the description so you guys can copy as well. No point wasting time on HTML and CSS. This is pretty much basic, the web page that we'll be serving, but all the business logic we'll add in a minute. So just open your terminal and run this command with cargo run, no default features, and the features as front end and binary as front end, just to build and load only our front end features. And now open your favorite browser and let's see how our UI looks like. There you go. This is how our UI looks like. Codeshare semicolon projects as the title, a huge text area where we can fill in anything, our text, and a share button. We can click this and copy the link and share with our friends. So all the major features of Codeshare IO will be implementing as I mentioned in the start. So let's get back to our IDE. Now let's move to the server side, where we'll add all of the server side handling of WebSockets, caching, and then we'll move to the client side and finish the calling logic and dealing with sockets. But first of all, we forget one dependency, so let's quickly add that, which is serde.json with version as latest and optional as true, and we only need it on this backend. So just add serde.json here and then build your project. Now let's move to model.rs, where we'll first add our model. So pub struct chat message. This will be the request or incoming body of WebSocket string, and derive serialize, deserialize, debug, and then the query param and the socket request, which we have is pub roam id as string and user id as a string, and here we'll derive deserialize. Then we'll add struct for response, derive serialize and clone. Here we'll add roam id and code, and then we have pub struct client, where we will have derive as debug and clone, and then pub user id as string and pub sender as Tokyo sync mpse unbound sender axiom extract WebSocket message. So this will be using for caching, and all other models will be part of our response or request. Now let's move to cache.rs and add our cache. So right here, first of all, we'll add a struct cache and make it clonable by adding this macro, and then we'll add a client cache arg mutex because we want to share the cache across threads. So hash map string as the room id and vector of client, and client comes from our model that we just added, which has a user id and the sender. So why do we create this cache, this room id and vector of client, is because let's say you went on our Codeshare page and you shared the link with your friends, so all those friends will be part of this, and then anything you type or they type in that room, it will be sent out to all of these users. And the second thing we need is a data cache. Now this one you can add in Redis or any other distributed database for that matter, but I'm just using in memory because I don't have any plans to run this in Kubernetes or deploy it somewhere. But ideally you should be using distributed cache to add this relation. And now we'll add impl cache pub fn new, and we return cache. So client cache as arg new mutex new and hash map new. Same thing we'll do for data cache, so just copy this and paste it here, and then we'll add a few APIs or functions to expose the data. So add data roam id and data let mutable cache self dot data cache dot lock unwrap, and then we'll just do cache dot insert roam id and data. Similarly, we have get data roam id as string, but we'll pass as immutable, and this returns us option of string. This cache we'll just need for history loading purposes. So let's say you type something at your end and then you share the link with your friend, so as soon as your friend goes to that link, they should be able to see that data that is being typed before they reach their link. So once we start using all of these, it will make more sense. So let cache self dot data cache dot lock unwrap cache dot get roam id dot map and data, and then data dot clone. Then we'll add client self room id string client let mutable rooms self dot client cache dot log dot unwrap and rooms dot entry room id or insert with. So it's kind of absurd. New and push client. So if we already have a key against which we have a vector of clients, we'll just push into that. Otherwise, we create a new vector and add into that. So finally, we need just get clients and self room id and string option of vector of client and let rooms self client cache lock unwrap rooms dot get room id dot cloned. That's pretty much all the functions that we need here. So now let's move to server. So first let's make this async Tokyo man and then let cache new to initialize our cache and then let app router new route send get and right here we'll just add our WebSocket handler and route. This is slash history id and get. Right here we'll add our history handler layer extension arc new and cache and then one more layer for cores since we'll make the call from front end which will be kind of cross origin call. So just to avoid cores errors and issues, for now we'll allow any origin and then let's add the listener Tokyo net TCP listener bind and for the backend we'll use port 4000 since we already use port 3000 for front end and we'll just add the serve. So listener app await unwrap. Now let's add the history handler. So async fn history handler. This will have a path id path as string and then an extension cache which is extension arc and cache. Now right here we'll just return a result which is either a string or in status code. So match cache dot get data by room id. If we get the data we will return some code. Remember this we'll just use for loading the history. For real-time communication it's all WebSockets. So code and for none we'll just return an error saying status not found. That's our history handler and we use it right here. Now let's add our sockets. So let's move to socket.rs. Here first of all we'll add a WebSocket handler passing extension as arc cache and extension of cache WebSocket upgrade and query params as query params and query param model that we added in the start, which is having room id and user id which we will pass in our WebSocket request, and then impl into response WebSocket on upgrade and move Now let's add the handle socket, where we'll add all the business logic, all the brand of this Codeshare application that we are building. So arc to share across threads, and then we just need query param. Let's call handle socket, pass the socket cache and query param. Now right here, first we add a channel, mpse unbounded channel. Let's socket arc new and mutex to share the socket across threads, and then we'll add our client to the cache, query param room id clone, and client user id as query param dot user id clone, and sender as dx. Then we'll add loop Tokyo select some message rx dot receive, and println sending message to client. So let's code it, and then I'll explain you guys line by line on what's happening. If you have any problems still, then feel free to ask me questions in the comment. Await, so if socket dot send message dot await dot is error, then we'll just print saying fail to send message, closing connection, and break. Else we'll just do result async and let mutable socket dot log await and socket dot receive await, and then we'll work on the result. So match result some okay message, then we'll just match the message, and if it's a message text, then we can just print saying received text message with whatever the text is for debugging purposes, and then we'll try to parse the message. So Saturday JSON from str and our model, which is chat message. So let's import this and text. So we'll just say cache dot add data and query param room id clone and query param dot code, or actually we will use the new message dot code dot clone. Then we will check what clients are connected. So clients dot get clients and query param dot room id. If that's the case, there are some users connected, then we'll just say for client and clients print saying broadcasting message to client dot user ID and we'll just add a response, which again comes from our models that we added in the start with room ID and code. This will what we'll be returning to all those users in case there is some change. So room ID query param room ID clone code as new message dot code dot clone, and finally client dot sender dot send message text and pass JSON to string. So here we'll just pass our response. That's all that we need here. Now let's add the else part. So if there are clients connected, then we send out the message, but if there are no clients connected, then we'll just print saying this is for this one. So we just say no clients found in room and query param dot room ID. Then if that's not the case, but the case is that we are not able to parse the message, then we'll also say fail to parse the message. And if that's not the case as well, actually let's print so we know if there's something invalid. Then we have the message text, but if that's not the case and we get some other message which is, let's say, close connection from client, then we'll just print saying client disconnected and we'll break out. And if that's not the case, there is a ping or pong message, then we just ignore it as it is. And if that's even not the case, there is no sum, there is no okay message, then we just break out. So here we'll just say if that's not the case, then just break. So let's try to understand. First of all, we add a MPSE channel, a receiver and a sender, and we have our socket here and we receive from socket. So if we get any message which is a text message, then what we do is we add it in the cache and we check what are the clients that are connected to the same window or the same room. Room is just a concept for code, but you can assume as a window for code sharing. Then we share with all of them by just broadcasting to this client sender. Sender is just this MPSE sender. We just broadcast to this channel, and then we have a receiver for this channel which receives and then use the same socket and just send out the message to our receivers. So that's pretty much all that's happening. It's pretty simple. If you still have any questions, feel free to leave in the comments. And if we receive a close message, we just disconnect the client. So that's all from our WebSockets. Our server side is ready. Now we'll move to the client side, and where we will use our sockets and our history endpoints in HTML file. Just one last thing before that is move this and paste it here. So let's move to index.html, and here we will add a script tag. And first of all, we'll add a generate unique ID function. Generate unique ID, and we can just return math dot random dot toString. Let's say we generate a random string of, I would say, 30 characters, and we just use it. So what happens is, as soon as a user comes to our page, we assign a user ID and then a room ID. So room ID, first we'll check if we have it in URL parameters, window location search. If we have it, we'll just get it from there. But if it's empty, then we generate a new unique ID. And then we add socket. So const socket new WebSocket, and pass our URL. So localhost and 4000 our backend. Send is what our endpoint is, and we pass a couple of query parameters. So user ID as user ID, and we pass room ID as a room ID, and then we'll just add window dot add event listener on load. If that's the case, we can just say here console.log user ID, and just for the debugging purposes I'm adding this user ID and room ID as room ID. So if there is some room ID, then we try to fetch history, which we'll add in a minute. So let's add fetch history. Async function and fetch history room ID. So try and let response await, send a fetch http localhost port 4000 slash history slash room ID, and if we get the response that is okay, then we'll just get the data. So await response dot text. If data some data, then we can just do document dot get element by ID editor dot value and just set the data in the editor. If that's not the case and we get any error, then we can just console log the error. Now let's add the share part. So we'll just say document dot get element by ID share button, add event listener, and the listener that we'll add is click. So when the button is clicked, we want to copy the URL. So we'll just say const share URL. Let's construct the URL. So http localhost port 3000, the front end, room ID as room ID. So this user will join using the shared URL room ID. So a new room ID won't be generated and will join in the same room. So Let's copy this on the clipboard. So we'll just say const type text plain and const blob, or let's add this in a separate method actually, just for better readability. So async function copy text const type text plain const blob new blob and text type const data new clipboard item and pass the type blob and await navigator dot clipboard dot write data alert, just showing share URL copied to clipboard. So let's use this copy here, pass the share URL. Now the next thing we'll do is the socket stuff. So socket dot on open, and we'll just say console dot log WebSocket connection opened document dot get element by ID, get the editor at event listener on input. Now we can add some throttling here, but for now we'll just send as the user is typing. So const code document dot get element by ID editor dot value const message code user ID as user ID and socket dot send JSON stringify message. So this is on socket open, and on the message we'll just say socket dot on message event, and if there's a new message received, then first of all we'll parse the message JSON dot stringify event dot data, and if message dot user ID not equals to user ID, or actually we don't need this condition, we can just do document dot get element by ID editor dot value message dot code. Now the next thing we'll do is socket dot on error, we can just console log the error. So we can just say console dot log error, and then the final thing socket dot on close event console dot log, and we can just say disconnected. So let's add semicolon here, 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 and here, and here. Actually we don't need. So that's pretty much all that we need for our logic. For the first time, let's go ahead and spin up our server client side and test our application. So open your terminal, and first of all we'll just spin up our backend. So cargo run, no default features as backend as we define in our cargo toml file, and bin as backend. So there you go, our backend is up and running. Now open a new terminal, and here we'll run our front end. So we'll just do cargo run, again same, just front end. So our both front end and back end are up. Now let's go to a browser and test our application. So let's add some code here. Let x as 10, and then we copy our URL by pressing the share button. We see alert which we added, which is share URL copy to clipboard. Now let's add a new tab, and as you can see, as soon as we come on this URL, we see the code already. But let's go back and try to add something more. There you go, the semicolon is there. And let's say this user, the user 2, now makes some change and says if x is null, and we go there you go, and then he tries to remove it. This guy also sees it removing. But if a user goes to a new URL, as you can see, this guy, the third tab, goes to a new URL, and whatever the changes is here, he doesn't get it. He also doesn't get it. Only these both get. But if he adds something, let's say print ln hello world, then this user doesn't get it, this user doesn't get it, because they both are sharing the same link. This user is having a different link. Now let's share his URL and open in a new tab. As you can see, as soon as this guy loads the page from history, he sees hello world and he tries to remove. This is removed. Let's say this guy removes world. This is removed, but no change on this side. Again, this guy removes this, the change. So it's completely synced with WebSockets. It's super fast. So that's it for our first major project on my YouTube channel. Please feel free to leave your feedbacks on how can we improve, and press a thumbs up if it really helped you and you learned something new.